Hello there. In this video, Colin Heathfield from Cole-Parmer is going to be talking about progressive cavity pumps.
Dear, thank you very much. Now, progressive cavity, what is it and why do we call a pump type progressive cavity?
Yeah.
They are used within heavy industry. They are positive displacement. They are quite a unique type of pump. They fulfill a very vital role that nothing else really seems to get to. They are very, very good at slurries and sludges. There is a couple, or one alternative that might be, but if you see here, their big bonus is high viscosity liquids, low shear, non-pulsating. They are very, very, very clever design. If you imagine, when we look at it, this is the best way to describe how it works. If I talk about a piston pump, so imagine a piston. If you look at, on the screen, we have the piston pushing the liquid, which is shown by the area with the blues and the bubbles.
Yeah.
So imagine multiple pistons, all pushing the liquid at once.
Yeah.
So we're pushing this large amount of liquid behind multiple pistons. So now we make the wall thickness 0. So we make the wall thickness of those pistons almost non-existent, but they're still working there. Now if we change the shape of the pistons, you'll notice now there is a curve there.
Yeah.
So if we were just to push forward, it wouldn't. But imagine rotating it at the same time.
Ah, yeah.
And we've created the endless piston pump. So what you can see there is the grey area is a worm, a long metal tube that's an eccentric shape turning in a rubber housing. So you have a rotor turning in the rubber housing we call a stator. And it turns such that it's constantly connecting at some points down the length of it. And then you can see we have the pocket of liquid, which doesn't really show it. But you see the little tracked line?
Yeah.
These pockets of liquid do that the whole way through.
Oh, so they follow it around.
So there is almost a continuous path all the way.
Yeah.
So you've got to think of it in that whole 3D...
So that, yeah, so the liquid moves down and down and down. Okay, I understand.
By doing that, we've created this endless piston pump. So we're constantly moving this liquid along. We're pushing it like a piston, but not using a piston. We're just constantly chasing its tail to push it along. And it's an incredible way of doing it. Now, when we talk about what liquids would we pump with it and how would we do it, we can achieve good flow rates with these pumps. We can go up to 4-inch, 6-inch connections on them. You can get some very big pumps. Within the pumping world, we talk about end connections as a way of defining, although they go down to, I think, 1/2 inch is the smallest. They are for slurries, for foodstuffs. If you wanted to pump paste, if you manufactured a large amount of paste and wanted to move it, paste is abrasive. Paste is a foodstuff, so you need to keep it hygienic. One of these would be ideal. It would pull it in, and then you can push it to where you need, whether you're filling little pots and things like that. But you can move an abrasive and a thick slurry with these pumps. That's talking about foodstuffs. Because they're also low shear, they win on the foodstuffs, they can win on other valuable products. It's within the food industry very, very effective from being low shear. It's very, very effective as well for a lot of the clay slurries and china clays we use. So a lot of the ceramic ware that's used is also pumped with this. Now, the china clays and things are even more aggressive, abrasive. So we have to have, they do what they call nitriding on the rotors to make sure they don't wear out. They do many, many different things to ensure they last. They're also used a lot within sewage treatment works, which is part of the existence that people don't like to talk about.
Yeah.
But without these pumps and this type of pump, life would be a lot harder because they take a lot of what are known as primary sludges and secondary sludges away. The pressures they can achieve are greater than the alternative variety. So as I said, there is potentially another option of what can pump these things, but it can't achieve the same pressures. these can go to greater pressures, and you're talking in excess of 10, 20 bar in certain instances. It's down to your sealing arrangement, it's down to the motor driving it, it's down to the length of the rotor and the stator. So if you wanted to get a greater pressure, you could have a longer rotor and stator. You have to go bigger on a very specific scale to get the greater flow rates, but as I say, they're very good at what they do. Let's just bring into perspective. So here's the inlet.
Yeah.
There's the liquid moving through, and there's the outlet. So that's what's going on inside the pump, and then where I'm sitting would be the way of driving it. So effectively a motor through a coupling.
And what are the advantages of these progressive cavity pumps?
This was very, very specific. This is, as I said, they're very accurate. They're a positive displacement pump that can pump a slurry. So you get a very volumetric efficiency. Very good volumetric efficiency. They can do the high viscosity liquids. You can't do it with centrifugal, you can't do it with a lot of the other technologies. These can do it, and they can make it pulseless. So they can do that long line, that continual movement of. They have a very, very high accuracy, and they are low shear. So again, a lot of pharmaceutical products can go through this sort of pump because it's not pulsed and because it's delicate, and this will treat them delicately. Their biggest core things are the clay slurries for all the chinaware and things, and all the hand basins and all the toilets. And then from light fittings, there's a lot of chinaware or that sort of thing in light fittings and things like that. So they do all of that. And they can handle soft solids and foodstuffs. So they can push things without damage. Again, we were talking in another video about centrifugal pumps and potential damage. These don't cause the damage because they are that low shear, and they can be food grade, so you can pump through to clean them, and you just have to have a clean down regime. They can be industrial grade, you can have industrial motors. There are many, many variations. Is there a downside to it? Well, it's a pump for a very specific area. So, if you don't want to pump a slurry or a sludge or a foodstuff, then you don't want to look at this sort of pump. It's like a digger in the car. Well, you've got to have a need for it to use it. They do have a larger footprint. By that we mean the area they take up on the ground compared to other pump technologies. And maintenance of them can be complicated, although there is new versions coming out onto the market which have addressed this and dramatically improved it because it's been a known issue. There is companies continually looking to develop that maintenance and make it easier. It's an ongoing process, and there is a large number of moving parts because you have a rotor turning in a stator with a coupling and a drive shaft and a mechanical seal, and these things, it's more parts to wear, whereas if you consider another sort of like the peristaltic, which only has one moving part, the tube.
Thank you very much. So, Colin, that's an overview of progressive cavity pumps. And once again, if you have any questions about those, do contact the team at Cole-Parmer, and they will be more than happy to help.